The war ended before it could fight in it. The Lockheed P-80 Shooting Star was America's first operational jet fighter. Designed in 143 days, flying before Germany surrendered, arriving in Europe too late to meet the aircraft it had been built to counter. The pilots who flew it had to relearn everything. Jet propulsion changed how an aircraft accelerated, climbed, and stalled. The P-80 killed more American pilots in training accidents than it ever encountered in combat. It was the price of learning what came next. Over the Yalu River in 1950, American pilots encountered something that should not have been possible. The Soviet MiG-15 was faster than anything the United States had in Korea, climbed better, and flew higher. The answer was the North American F-86 Sabre. Swept wings, more powerful engine, a pilot who knew what he was doing. The MiG-15 and F-86 fought the first jet versus jet air campaign in history over a corridor pilots on both sides called MiG Alley. The kill ratio the Air Force reported has been disputed ever since. The swept wing template it established has not. Not every aircraft gets to be the one that changes history. The Republic F-84 Thunderjet flew in Korea at the same time as the Sabre, did most of the dangerous work, and received almost none of the recognition. While the F-86 fought MiGs at altitude, the F-84 flew low, flying over 86,000 combat sorties and accounting for nearly 40% of all USAF strike missions in the war. It absorbed anti-aircraft fire and brought pilots home in aircraft that should not have been flyable. It demonstrated that a jet capable of carrying bombs was worth more than a pure fighter that could not. The strike fighter, as a category, begins here. The Navy watched the Air Force fight in Korea and drew its own conclusions. The Grumman F9F Panther was not the fastest jet in the theater or the most celebrated. It was the aircraft that proved carrier-based jet aviation worked. Flying from fleet carriers in the Sea of Japan, Panther pilots attacked targets across North Korea and returned to a moving flight deck, a problem land-based aviation never had to solve. One of those pilots was Neil Armstrong, who lost part of his wing to a cable strung across a valley, flew the damaged aircraft back to friendly territory, and ejected safely. The Navy had its jet fighter. Speed alone would define the next decade. The Air Force wanted supersonic. The North American F-100 Super Sabre delivered it, the first production fighter capable of level supersonic flight. The engineers celebrated. The test pilots discovered the problem. At high speed, the F-100 had a tendency to snap into an uncontrollable roll called inertia coupling, a phenomenon predicted theoretically, but never encountered in a production aircraft at these speeds. The first prototype killed test pilot George Welch. The production aircraft killed pilots throughout its service life, at a rate that would end any program today. The Air Force kept flying it because the Cold War did not allow time to start over. Lockheed's Kelly Johnson asked Korean war pilots what they wanted. They said faster, higher, simpler. The F-104 Starfighter was that request taken to its logical extreme. A missile with a cockpit, wings so thin they could cut a ground crewman who walked into them. It flew at Mach 2. Its service ceiling exceeded any Soviet bomber's reach. It was also lethal to fly at low altitude in bad weather, prone to flat spins from which recovery was not guaranteed, and equipped with a downward-firing ejection seat that killed pilots below certain altitudes. Germany bought 916 for NATO service. They lost 292 in accidents. The pilots called it the Widowmaker. The McDonnell F-101 Voodoo was designed to escort nuclear bombers deep into Soviet territory. By the time it entered service, Strategic Air Command had decided it did not need escorts. Bombers would fly so fast and high that no interceptor could reach them. The F-101 lost its mission before it was fully operational. What saved it was Cuba. In October 1962, RF-101 Voodoos flew low-level photographic reconnaissance missions over Soviet missile sites at speeds that made them nearly impossible to intercept. The photographs they brought back forced the Cuban Missile Crisis into the open. The aircraft that lost its original mission documented the most dangerous confrontation of the Cold War. The Convair F-102 Delta Dagger failed its first supersonic test. The aircraft designed to intercept Soviet bombers crossing the Arctic could not break the sound barrier in level flight, a fact discovered only after the Air Force had committed to the program. The solution was the area rule, a principle showing that an aircraft's cross-sectional area had to change smoothly along its length to reduce shockwaves. Convair narrowed the fuselage at the wing root, creating the wasp waist shape that became standard on supersonic aircraft for 2 decades. The revised F-102 broke Mach 1 on its first flight. The engineering lesson it taught was worth more than the aircraft itself. The Convair F-106 Delta Dart was everything the F-102 had been designed to be and never quite managed. Faster, higher, better armed, the apex of the interceptor concept. Its fire control system could manage the entire intercept automatically, from radar acquisition through missile launch, with a pilot present largely to handle emergencies. In 1970, a pilot ejected from a Delta Dart in a flat spin. The aircraft recovered itself, landed in a snow-covered Montana field with minimal damage, and was repaired and returned to service. The Air Force flew it until 1988. The Soviet bombers it was built to stop never came. American fighters went to Southeast Asia instead and discovered that everything the previous decade had taught them was wrong. The McDonnell F-4 Phantom II entered service without a gun. This was doctrine, not oversight. Air combat in the missile age would be conducted beyond visual range. Radar lock, missile launch, kill confirmed. Rules of engagement over North Vietnam required visual identification before firing, which meant closing to ranges where the missiles were unreliable. Early Sparrows and Sidewinders failed at rates that appalled the pilots depending on them. The Air Force eventually bolted a gun pod to the centerline. The kill ratio that American air power achieved in Korea, better than 10-1, fell to under 3-1. The Navy's response was to open a school in Miramar and teach fleet pilots how to dogfight again. The Vought F-8 Crusader went to Vietnam with a gun and a doctrine built around using it. While the F-4 community was discovering the limits of missile-only combat, F-8 pilots operated with a weapons philosophy unchanged since Korea. Close the distance, put the pipper on the target, fire. The Crusader achieved a kill ratio nearly twice that of the Phantom over Vietnam. Its pilots were not better than Phantom crews. They were operating under different rules, with a weapon that worked at the ranges the war forced on them. The Navy looked at those numbers and reached a conclusion the next generation was built around. Missiles had not replaced guns. They had joined them. The Republic F-105 Thunderchief flew more combat missions over North Vietnam than any other aircraft in the war, and was destroyed by that war faster than any aircraft the Air Force had ever lost in sustained combat. Designed to carry a nuclear weapon at supersonic speed through Soviet air defenses, it was sent instead to drop conventional bombs on targets defended by the most sophisticated anti-aircraft network America had ever faced. In 1966 and 1967, flying the same route packages daily, Thud pilots faced SAMs, MiGs, and artillery simultaneously. The Air Force lost 334 F-105s in combat, out of 833 purchased. The pilots who survived came home and built something better. In 1972, the Air Force held a competition it did not entirely want for an aircraft several generals believed it did not need. The lightweight fighter program was the result of reformers who had studied Vietnam kill ratios and concluded American fighters had become too heavy, too complex, and too expensive. General Dynamics entered the YF-16. Northrop entered the YF-17. The YF-16 won. Its fly-by-wire controls, relaxed static stability, and blended wing body became the template for fighter design for 50 years. Pilots reported it responded to inputs before they had consciously finished making them. The generals who had not wanted it watched it become the most produced Western fighter in history. The YF-17 that lost was redesigned for the Navy and entered service as the F-A-18 Hornet. The Grumman F-14 Tomcat was built to solve a problem the Navy had been unable to solve for a decade. Defending a carrier battle group against Soviet bombers, launching cruise missiles from beyond the range of any existing interceptor. The answer was the AWG-9 radar, capable of tracking 24 targets and engaging 6 simultaneously, paired with the AIM-54 Phoenix missile, with a range exceeding 100 miles. No other aircraft carried anything comparable. Iran received 79 F-14s before the revolution and flew them through 8 years of war against Iraq, cannibalizing airframes as American support disappeared. When the Navy retired the Tomcat in 2006, it destroyed the spare parts inventory specifically to deny them to Tehran. The McDonnell Douglas F-15 Eagle has never lost an air-to-air engagement. In 40 years of combat, across multiple wars and multiple air forces, no F-15 has been shot down by another aircraft. The record stands at over 100 confirmed kills against 0 losses. It was designed after Vietnam around a single principle: not a pound for air-to-ground. The original F-15 carried no ground attack capability. It existed to achieve air superiority and nothing else. The airframe that doctrine produced proved so capable that it is still in production today, 50 years after its first flight, in variants carrying sensors and weapons its designers never imagined. The production F-16 Fighting Falcon was heavier and more complex than the YF-16 prototype that won the lightweight fighter competition. The Air Force needed multirole, not a pure dogfighter. It remained the most maneuverable fighter in the American inventory. Its reclined seat tilted the pilot back 30 degrees, increasing G-force tolerance enough to allow maneuvers that would render pilots in conventional seats unconscious. Over 50 nations have flown it. More than 4,600 have been built. Israeli F-16 destroyed Iraq's Osirak nuclear reactor in 1981. American F-16 flew the first missions of Desert Storm. The aircraft the generals had not wanted became the most versatile fighter the Western world had produced. The McDonnell Douglas F/A-18 Hornet should not have existed. The Northrop YF-17 it was derived from had lost the lightweight fighter competition. The Navy needed a replacement for both the F-4 and the A-7 attack aircraft, and saw something the Air Force competition had not evaluated: an aircraft that could do both jobs. The Hornet that entered service in 1983 could fly fleet air defense and ground attack from the same carrier, requiring only a change of weapons. Pilots who had flown single-role aircraft their entire careers could do both missions in a single deployment. The aircraft, built from a competition loser, replaced 2 separate aircraft and became the backbone of carrier aviation. What came next would be invisible. The Lockheed F-117 Nighthawk was publicly acknowledged in 1988, 11 years after it first flew. An aircraft shaped like a collection of flat panels should not have been aerodynamically flyable. It was not, without its fly-by-wire computers running at all times. On the first night of Desert Storm, January 17, 1991, F-117s struck the most heavily defended targets in Baghdad, while conventional aircraft attacked the periphery. The pilots who flew those missions described it as operating in a different war from the aircraft around them. In 1999, over Serbia, one was shot down, the only F-117 ever lost in combat, brought down by a Soviet-era crew that had studied how to find it. The wreckage was examined by every nation with an interest in what it revealed. Northrop built the better aircraft and lost the contract. The YF-23 Black Widow II competed against the Lockheed YF-22 for the Advanced Tactical Fighter contract in 1991. By most technical assessments, the YF-23 was faster, had a lower radar cross-section, and was stealthier from the rear. Lockheed's YF-22 was more maneuverable, and its program management was considered lower risk. The Air Force chose the YF-22. The two YF-23 prototypes went to museums. The engineers who built them carried design lessons forward that influenced stealth aircraft for decades. The aircraft that lost is remembered more clearly than most that won, a recurring feature of programs where the deciding factor was not which aircraft flew better. McDonnell Douglas took the F-15 airframe built around the principle of not a pound for air-to-ground and built a strike aircraft out of it. The F-15E Strike Eagle added a second crew member, conformal fuel tanks without drag penalty, and a ground attack system capable of precision weapons delivery at night and in weather. In Desert Storm, it flew deep strike missions against Iraqi targets no other coalition aircraft could reach. In Afghanistan, it flew close air support and precision strikes in the same deployment. The airframe built to fight other aircraft became one of the most capable strike platforms the Air Force operated, without surrendering the air superiority capability that made the original F-15 untouchable. The Lockheed Martin F-22 Raptor cruises at supersonic speed without afterburner. Its radar cross-section is comparable to a marble. Its radar detects and tracks targets at ranges where those targets have no sensor capable of detecting the F-22 in return. It sees first, shoots first, and the adversary never knows it was there. The Air Force planned to build 750. Congress funded 187. Unit cost had risen to over $350 million by the time production ended, making further procurement politically impossible. The most capable air superiority fighter ever built was manufactured in numbers insufficient to replace the aircraft it was designed to succeed. The production line closed in 2011. It has not reopened. The Boeing F/A-18E/F Super Hornet shares a name with the original Hornet and approximately 20% of its parts. Everything else was redesigned. Larger, more powerful engines, greater range, better radar. It entered service in 1999 as a bridge aircraft after the Navy cancelled the A-12 stealth bomber program and needed something that could operate from carriers immediately. It was not designed to be a long-term solution. It became one. The F-14 it replaced was retired in 2006. The Super Hornet is still the backbone of carrier strike aviation today, flying missions the aircraft it was meant to bridge toward. The F-35C has only recently begun to take over. The temporary solution outlasted 2 generations of permanent ones. The Lockheed Martin F-35 Lightning II is the most expensive weapons program in human history, over $1.7 trillion across its projected lifetime. It was designed to replace 7 different aircraft across 3 services, with 3 variants sharing a common airframe. The compromises required to serve 3 missions delayed the program by years and drove costs to levels that produced congressional investigations and the kind of sustained criticism that ends most defense programs. The F-35 survived it. Its sensor fusion, combining data from multiple onboard and offboard sensors into a single integrated picture for the pilot, is a generation beyond anything its predecessors carry. 11 nations operate it. Whatever its program history cost, the aircraft it produced works. The Boeing EA-18G Growler is what the military builds when it concludes that destroying an enemy's ability to communicate is worth more than destroying his aircraft. Derived from the two-seat F/A-18F, the Growler carries equipment capable of detecting, jamming, and suppressing enemy radar and communications across a wide frequency range. It accompanies strike packages into defended airspace and blinds the air defense systems that would otherwise engage the aircraft it is escorting. It is the only dedicated carrier-based electronic attack aircraft in the world. Every nation that operates strike aircraft and does not have one understands the capability gap. None has been able to fill it. The Boeing F-15EX Eagle II is a new production aircraft built on a 50-year-old design, and the Air Force buying it is a statement about what fifth-generation fighters cannot do. The F-22 and F-35 carry weapons internally. Stealth requires it, and internal bays limit payload. The F-15EX carries up to 22 air-to-air missiles on a single aircraft, including weapons too large to fit inside any existing internal bay. It costs less than half as much per unit as the F-35. The Air Force that once closed the F-15 production line reopened it because maximum payload in permissive airspace remains a mission stealth aircraft cannot perform. The aircraft designed in the aftermath of Vietnam is still being built. The next-generation air dominance fighter, recently designated the F-47, is designed to replace the F-22 in the air superiority role. The Air Force has confirmed a prototype has flown. Performance specifications remain classified. What can be inferred from the requirements it was built to meet is significant. The F-22's stealth geometry was designed to defeat radar systems that existed in the 1980s. Chinese and Russian investment in low-frequency radar has reduced the margin that first-generation stealth provided. The F-47 is designed for an environment where stealth is necessary but no longer sufficient, where an aircraft must also outmaneuver, outrange, and outprocess the adversary simultaneously. The Kratos XQ-58 Valkyrie costs approximately $3 million per unit, roughly 1% of an F-35. It carries weapons internally, flies at transonic speeds, and operates at ranges that would exhaust a human pilot. The Air Force describes it as attritable, designed to be expendable in environments where the cost of losing it is acceptable. The concept is direct. If an adversary system forces a choice between losing a $3 million drone and a $150 million aircraft with a pilot aboard, the drone loses. The pilot comes home. The XQ-58 has completed multiple test flights in coordination with F-22s and F-35s. The Collaborative Combat Aircraft Program is the Air Force's formal framework for what comes after the XQ-58 experiment, where the Valkyrie demonstrated that unmanned jets could fly alongside manned fighters. The CCA program is designing the system, the doctrine, the communications architecture, the rules of engagement that turns individual drones into coordinated wingmen. A single F-47 pilot operating with a package of CCA aircraft would control more firepower than a traditional four-ship formation, while presenting a more complex targeting problem to any adversary. What began over the Yalu River in 1950, with two pilots in swept-wing jets trying to get behind each other, has become this: autonomous systems coordinated by a single human at a distance, engaging targets the human may never see.